So in this question, we've been given that two plane electromagnetic waves are moving in vacuum in whose electric field vectors are given by E1 vector and E2 vector. Now at t is equal to 0, a charge q is at origin with velocity 0.8 cj, where c is speed of light in vacuum. Okay. The instantaneous force on this charge. Okay, so we have to find the instantaneous force on this charge. Let's see how to find that. Now, we have been given that the magnetic field vectors are E1 and E2. Since the variation of E1 vector and E2 vector is along x and y directions, respectively, therefore, direction of propagation of E1 and E2 will be along x and y respectively. Now, since E cross B gives direction of propagation and E naught by B naught is equal to C, and variation of magnetic field will be same to magnetic field. So the magnetic field vectors of the electromagnetic wave are given by B1 vector and B2 vector respectively. Then force is F is equal to QE plus Q V cross B, which simplifies to this. Alright. So now if we put the values of E1, E2, B1 and B2, we can get the net Lorentz force as this, right? Putting values and solving, we get F is equal to QE naught cos kx minus omega t j plus cos ky minus omega t k plus 0.8 cos kx minus omega t I minus 0.8 cos ky minus omega t k. Now, at t is equal to 0 and x is equal to y is equal to 0, we get this.